Hello and welcome everybody. My name is Pavol Loffay and I will be talking about MicroProfile OpenTracing and looking beyond to OpenTelemetry project. Before we start, I would like to know who of you is using distributed tracing in your companies, right? Okay, so on today's agenda there will be a brief introduction to distributed tracing as a concept in general. Then we will deep dive into MicroProfile OpenTracing specification. And I will do a demo on Quarkus with Jaeger tracing system. And last but not least, I will talk about OpenTelemetry. I will do some introduction and I will mention like how we can integrate OpenTelemetry project inside MicroProfile. Before we start, just a couple words about myself. I'm a software engineer at Red Hat. I've been working on distributed tracing for about the last 3 years. And on daily basis, I work on Jaeger, OpenTracing, and OpenTelemetry project. So if you want to talk about any of these, feel free to reach out to me. So first of all, we have to ask this question: why tracing? Why should we care about distributed tracing at all? And the answer is actually very simple, because modern architectures, modern systems are very complex, are very hard to understand what is happening inside. And for example, nowadays, when you're loading any major website, the data which is required for you, it can hit maybe dozens or hundreds of services. So just loading a simple page means complex computation in your environment. And it might look like something like this. This is actually a screenshot from Jaeger tracing system. It shows an infrastructure in Uber. There are maybe like 2,000 services. So each node represents a service. And when you load the page or web app, the request usually goes to maybe dozens, hundreds of services. So it's quite complex invocation. And the question is, how do we understand what happens with such a request? And this happens, for example, like thousands, billions, millions of times a day. So the question is, what do we do when something goes wrong? We want to actually pinpoint the error in a specific service, but also in a specific component inside that service. And traditionally, we used to use metrics and logs to understand our applications. But there is a problem with distributed architectures, because metrics, they kind of provide like executive view on the system, what is happening in a big picture, but there is no context. You see some spikes, but you don't know why. With logs, there is context, there is a lot of context, but it's almost impossible to correlate these events together and actually to find out what happened after specific log or just before. So these two observability techniques doesn't provide enough value for distributed architectures. So ultimately, monitoring should tell you the story, what happened with each single request. You should be able to tell like what services were involved and what kind of metadata were sent between these services. And metrics and logs doesn't provide this. So the answer is to use distributed tracing. So before we deep dive, I'd like to quickly demonstrate how tracing works at a high level. So imagine there is a service A which is exposed to the internet, and there is a request coming to your ecosystem. And what tracing does, it creates a unique ID called trace ID. This ID is put into the context, which can contain more metadata. And this context is sent to all downstream services. It's propagated to all services. And the invocation in the service is modeled with a span. So that line A represents an invocation in a service A. You see it has some duration, so we are able to tell how long it took to process the request in a service A. When service A calls any downstream services, the same thing happens again. The context is propagated, and tracing creates spans for each invocation in each service. So then we have something like this, which might remind you of Gantt chart. And you are able to tell a couple of things about this invocation. For example, that service A first calls service B, and after the invocation in service B, it calls service E. So maybe you could optimize this and call service B and service E in parallel. So the foundation of distributed tracing is really the context propagation. And to propagate the context from service to service is actually very simple, right? You just put the trace ID is the context into the request headers, and that's it. But the problem is that we have to propagate this context inside our applications. And in Java, we can use something like thread locals. You know, when the request arrives, we put the context inside the thread locals. And on the client side, when we are calling any downstream services, just get the context from the thread locals. Very simple thing. But the problem is that our code nowadays is very complicated. We use a lot of thread pools, queues, and futures. So basically, thread locals just doesn't work anymore. So in context propagation is usually the hardest thing to do in tracing. So this brings us to MicroProfile OpenTracing. So what is OpenTracing? OpenTracing is Cloud Native Computing Foundation project. It defines tracing API and a specification. So the API is defined in many languages, is vendor neutral, and it does basically nothing, just an API set of interfaces. There is no data or wire format, so if somebody says, I'm receiving OpenTracing data, it's nonsense because there is no data format. Nor there is a wire format. When I was talking about this context, which is propagated from service A to service B, OpenTracing doesn't define that. Every tracing implementation defines like what is the format of the context sent between services. And there's also specification, which defines like what kind of metadata is attached to each individual span. So, for example, HTTP request is represented with the same, labels for each service. So in MicroProfile, we took OpenTracing specification as it is, the upstream, and we exposed the API inside our deployments. We also added a couple of new APIs to make it easier to work with in Java EE environments. And we defined, we use the OpenTracing semantics to describe events inside MicroProfile. So the spec is divided into really two parts. The first one is called auto-instrumentation. It means that you basically don't have to do anything in your applications. You just drop jar in your class path. And for example, JAX-RS and MicroProfile REST clients are automatically traced. So on this slide, you can see there is a REST endpoint hello. When you create a request to this endpoint, tracing will automatically send data what happened in the invocation. The other part of the spec is explicit instrumentation. This is more for power users. It allows you to change tracing and define additional events. So, for example, you have complicated business code. So this allows you to instrument the business code to get timing information about it. There is trace annotation, which you can use on CDI beans or REST endpoints. You can change the operation name of a span, or you can just disable tracing. The other thing is that you can inject a tracer, OpenTracing tracer, and use the full OpenTracing API. This also allows you to use any OpenTracing instrumentation from upstream. So, for example, you are using JDBC or JMS, you can use upstream, upstream OpenTracing libraries to automatically trace these technologies. Then there is configuration. We use MicroProfile config to configure OpenTracing. There are two properties at the moment. The first one is to configure the operation name for server-side JAX-RS events. So either you get the HTTP verb with the class name and the method name, or you get the values from the path annotations as an operation name for server-side JAX-RS events. The next property is skip pattern. It's useful when you have some APIs you don't want to trace. You just define, regex, and those APIs will be excluded. So now I will do the demo on Quarkus. Okay, so it's basically very simple Quarkus application. We're just using JAX REST, so REST Easy, REST Client, and OpenTracing. In Quarkus, OpenTracing automatically pulls in Jaeger implementation, but conceptually you could use, yeah. Is it better? Yeah. So there are basically three dependencies: REST Easy, REST Client, and OpenTracing. OpenTracing pulls in Jaeger, but conceptually you could use any OpenTracing implementation like Zipkin, Lightstep, or basically any. Then there is REST endpoints. It's very simple. Just say hello, it returns hello. Say bonjour, returns bonjour. Then there is conversation service, conversation endpoint, which calls the service, or the CDI service, which has a REST client, and the REST client defines two endpoints, hello and bonjour. It basically calls itself, so the application calls itself. Just to demonstrate the context is propagated, on the wire. Then there are some properties. We will use the HTTP path for the server-side events, and we will exclude foo endpoint from tracing. Then you have to configure, every tracing system has a configuration. You usually have to configure the service name because the tracing doesn't know what is the service name from the runtime. Then you have to usually configure the sampler. We'll use constant sampler, basically sample all requests, and then the endpoint for Jaeger to, it sends data to this endpoint. So I will just run Jaeger server and redeploy Quarkus. And let's try to do a request. So we call hello, it returns hello. I call bonjour, it returns bonjour. And let's try to do some talking. So bonjour and hello. So now we should have some data in Jaeger. So this is the main search page in Jaeger. You have to choose the service you are looking for. So in our example, it's tracing example. We define that in the application properties. And then it shows all the requests or the transactions what happened and this service, where this service was involved. So we see information like we call the conversation as the first endpoint, or there was a request to the bonjour or to hello. We see how many operations were there. So this one is with the chaining calls, and this one is just for a single bonjour endpoint. We see the overall duration, and of course the time. If there is an error, it will also show what the number of errors would happen in a service. So let's choose this one. I think when I first look at this graph, it looked a bit overwhelming because there is a lot of information, but it's actually very simple very simple to understand this screen. So on the left side, we see the service names. So in this case, it's always the tracing example because tracing example calls itself. And then there is the operation name. So this is really the value from path annotations. It's maybe good to collapse them all. So we see the first endpoint. We open it. We see the conversation called like this API, and then this API called made two calls. If I expand them all, I see that it called like two different endpoints. When I zoom in into each individual span, I see what metadata is attached. So we see tags, we see like what was the status code, what component reported this span, what is the span kind. It's a little bit more complicated because when you are creating a call to a server, the server models the invocation. So the span kind is a server. But when a client creates the same call for the same URL, the span kind will be the client. So you have always, for HTTP calls or any RPC, you have usually two spans, the client and the server. And there is some Jaeger metadata. What is missing here, but if you can also attach logs to your spans, and you will see the timestamps. So there is a difference between tags and logs. Logs are timed, and tags are just any metadata which apply for the whole invocation of the span. So what we can do, we can, for example, use trace annotation to override the operation name. So instead of bonjour, we can say just hi. So let's have a look. You see, so there is no bonjour anymore. We changed the operation name. But you can also do. So let's have a look in the conversation service. So conversation service is CDI bean, and CDI is not automatically traced. We have to use this traced annotation to create spans for it. But for example, the greeting service, the MicroProfile REST client. So let's try to do this. Let's remove this trace annotation. So we will not produce spans for this service. And let's have a look if the REST client is able to connect to this trace what is happening. So before we had 6 spans, and now we should get only 5 because we are not tracing the CDI invocation. It's important to understand that the context, the span context is always propagated even though we are not creating so many spans. Yeah. Yes. Yes, so JAX-RS, it is automatically because we see this conversation span, which represents server-side JAX-RS request. And then this hello, which also represents JAX-RS service. So I removed trace annotation from a CDI bean. This is a CDI, right? So we are not getting the span for the CDI. So it's not present here, but when I go back, this has a 6 spans, And the CDI is this one, which contains, the package name, class name, and the method name. Yeah. So the main idea of the spec is to provide tracing capabilities out of the box, so you don't have to write the code in your application. But if you want to, you can still use the full API to create any additional events. I will go back to slides. So on potential roadmap, there are a couple of features we can work on. We can improve the operation names for REST client, because at the moment, if I go back, the REST client contains only, the operation name is the HTTP verb, which is like get. It's very generic. It doesn't tell you like, but if you're looking for this specific span, it's very hard to do it because all invocations for REST client will have the HTTP get. So in the UI, you will choose the get, which can be like many different calls. Then we would like to introduce maybe more annotations, so you could add tags to the active spans, and also do automatic tracing for CDI, which basically you can do two things: either like enable all CDI to be automatically traced and provide some kind of exclude pattern, or exclude all and provide include pattern. So you would write like a package name and all beans inside the package will be traced. Then there is ongoing discussion with MicroProfile reactive messaging. We would like to trace the messages going through. And also fault tolerance. With fault tolerance, the main problem is that the context is not being propagated out of the box. Yeah, so maybe once these two will depend on the context propagation spec, it will make the things easier. So this brings us to OpenTelemetry. To propagate the context across different tracing systems. And data format is also very useful because a lot of applications, for example, like Envoy, they wanted to use OpenTracing, but they couldn't because we didn't have data format. And they didn't want to include all the tracing or the OpenTracing implementation and compile them into single binary. This doesn't make sense. So they end up using Zipkin because the project provided a data format. The scope of the project is a little bit bigger than tracing. There is tracing, but also metrics API, and maybe sometime in the future logs. How we integrate these together? So we will provide the same events will have the same metadata attached to it. So all the HTTP metrics, related metrics, will have the same tags as the HTTP traces spans. And also, when I showed the context, in OpenTracing there is this term baggage, which is you can put any value inside the context, it will be propagated. So for example, a good example is to use, for example, the user agent. You can put their user agent in your first service, which is exposed to the internet, and then user agent is propagated to all services. And then, for example, with Istio, you can route some of the downstream services based on the user agent. So for example, you can redirect, iOS user to different version of a service than other users. But what is good with this in OpenTelemetry, you can use this baggage to split the metrics. So you can include baggage values inside your metrics tags. The APIs, like the tracing API, is very similar to OpenTracing and OpenSenses. It provides the same features, but it's different. It's a breaking change. One of the biggest changes is how we get the tracer. There will be a concept of so-called like named tracers. So you will provide the name and the version. This is useful when you would like to disable tracing for specific component. So let's say the MongoDB client is creating a lot of spans which doesn't provide any value to it. You can then simply disable it in the configuration. And other big change is agent and collector. So we took it from OpenSenses. So before you basically instrumented your application with OpenTracing, you use specific tracer and you had to stick it with it. You couldn't change it. If you wanted to change it, you had to rebuild your application and redeploy, which is a very expensive thing to do, right? So with agent and collector, it's actually the same component, but you can have two different deployment models. So the agent allows you to receive data in any format. Basically, you can use the OpenSenses, which should be OpenTelemetry, but you can also send the data from Jaeger, Zipkin, and other tracing systems if there is the receiver for it in the collector. So you can get the data and then you can send the data also to the collector, or you can export to your tracing system. So this way you can change the format in the collector and export it to a different system. You don't have to redeploy your applications. There's also we would like to do also tail-based sampling, like the sampling which happens after the event. And the collector is necessary because we have to keep all the data in memory for some time and then decide whether the span is interesting and we collect it or not. Okay, so how can we integrate OpenTelemetry in MicroProfile? There are a couple of proposals. We can either create a new specification for OpenTelemetry. It will be probably very similar to OpenTracing, just we use the different API. Or we can expose the OpenTelemetry inside MicroProfile OpenTracing. This is a little bit. This will provide us one feature that we could. The spans started in OpenTracing could be continued in OpenTelemetry inside a single process. Then there is a hybrid model that we could create a new project for OpenTelemetry and in OpenTracing update the current API to the latest version, which allows us to use the so-called shim, which is OpenTracing implementation baked by OpenTelemetry. Or maybe the last proposal could be define our own tracing APIs in MicroProfile. This is a little bit tricky because I think we should still allow to use upstream instrumentation for instrumentations from OpenTelemetry ecosystem if people want to trace any additional technologies. Okay, so last slide. My recommendation is to start with distributed tracing as early as possible, because if you want to use it, you have to really instrument all your applications, and once you have like hundreds of applications, it's very difficult to start, because if you just instrument some of them, you will not get any value from tracing. And if you care about MicroProfile and about tracing in MicroProfile, there is a proposal on the mailing list, so anybody can go and vote what is the best approach to go forward. If any questions? Yeah, yeah. It's it could be tracing system could implement some filtering, but by default, you know, the instrumentation APIs send all the data. Some libraries, yeah, some libraries they provide you with a filter, so you could potentially filter out some events. Yes. Yeah. Yeah, so we don't define the tracing backend, the storage. So this is really a feature of the implementation. Well, not in the moment, but it also depends how you send this data. So if it's like in your payload, it wouldn't be logged at all. If it's in the in the URL, yes. We do not touch the payload at all. Yeah. Yes. Hmm. So the question is about performance impact, and if you measure performance impact of the instrumentation, it's usually in isolation. You will usually see very little difference, like almost nothing. But when you deploy it in your environment, it will change because the traffic from sending the data to the tracing system will affect the latencies in your ecosystem. So you should really measure it in your real environment rather than in isolation. Then how to deal with that, right? You can change the sampling. So you can say I will sample only 1% or even less of the requests. It's part of the implementations. It's in OpenTelemetry it will be part of the spec, but in OpenTracing is part of the implementations. Yeah, usually all of them offer some kind of sampling, at least like probability sampling, where you can define like what percentage of the spans will be sent to the tracing system. Yeah, so it depends on the tracing implementation. In Jaeger, we have this configuration. You can change it on the server, and it will be propagated to the cloud. More questions? So yes, so I'm part of the Jaeger team. We are collaborating with OpenTelemetry. We are working on different parts of the system. So, for example, we are doing some work on the spec level in the Java API, and also we are working on the operator for Kubernetes. So where you would define how the collector and agent will be deployed. So then you can send the data. But as in Jaeger, for example, we would like to actually deprecate our components and use OpenTelemetry instead. So if you want to use OpenTelemetry with Zipkin or Jaeger, it's actually very minimal work for Zipkin community to integrate with it. it's hard to say. I think some SDKs have Zipkin exporter and Zipkin receiver. Yeah, there's also a specification or proposal saying like how Zipkin events should be, created from OpenTelemetry API. Such things. So I think the date is not set yet. It will be sometime in like next year. On the spec level, there is a document outlining the features we want to get in and when it will probably happen. Okay, thank you very much.